Alright, on Chapter 7, Section 2, let's get to the Part B question you had an issue with. So, we know our sample size, we know the number of successes, and we want a 95% confidence interval. So, if we are just doing this in StatCrunch, we'll go to proportion stat, one sample with the summary. Successes was 600 and observations was 983. That was a 95% confidence interval. And so this will give us our lower limit and upper limit. The point estimate, that's our sample proportion, so 0.610. The margin of error. So if 0.610 is our sample proportion and we add or subtract the margin of error, it's a p hat plus or minus e. To find the margin of error, you would just take either your upper limit and subtract the sample proportion, or you take the lower limit, or the sample proportion and subtract the lower limit. So let's just subtract one of these. I think we did an example like this in number 2 or 5, so you could check that one too. But if we have 0.64086186 and we subtract 0.61033764. So just taking your upper limits, subtracting your p hat, your sample proportion, we get 0.030. And 0.0305 looks to be about. And so that is our margin of error. Again, here's your confidence interval. It's 0.5799 to 0.6409. So that will help you with part B of number 3. You also had number 9 you had a question on. And again, we're still dealing with proportions. So assume that we want to be 90% confident. Again, using StatCrunch. Let's just make sure how many must be surveyed. We want to be within 2 percentage points of the true population. And it doesn't give us any previous information of a statistic. So I think when you're looking at the formulas in the text, they talk about using your P to be 0.5. So if you don't know anything about a previous sample taken, you would just use a 0.5. In StatCrunch, we would go to proportion stats, one sample, and we're trying to find sample size. We go to this confidence interval. It said we wanted to be 90% confident and within 2 percentage points. So our confidence is right here. We're going to keep this at 0.5. Now our width, so that's plus or minus our margin of error. So if our within 2 percentage points, that means 2 percentage points to the left and 2 percentage points to the right. So the width of that would be 0.04, 0.02 to the left, 0.02 to the right. And then we will find our sample size. It'll just give it to us, 1691. If you want to use the formulas in the book, I know a lot of people aren't using StatCrunch, which saddens me. But if you're looking at the formulas, show you the formulas that you should be using. And again, it's going to find the same number that we got using StatCrunch. Eventually we'll get there. So it should be at the end of this section. Let's see. There's that p hat plus or minus e we referred to earlier. Sample size. So again, we're going to have a couple formulas. If we have an estimate, a previous known p hat, we use this formula. If we don't, we use this formula. And again, this is similar to this one because if we're assuming p is 0.5, that means q is 0.5, and 0.5 times 0.5 is 0.25. But again, I'm going to tell you that I am a fan of using StatCrunch because it's easier, and we're just trying to figure out the sample size. You just have to know what to type in. The width is the thing that most people forget because it's double the margin of error. So 0.02 to the left, 0.02 to the right. The other one that you had a question with was number 12, I believe. So I guess this one we're doing a sample size should be the same way. To be 90% confident that his estimate is within 6 percentage points. So that's our E. So our width would be double that. So 0.12 percentage points. And our confidence level is the 0.90. So just do things similar that you did in number 9, and you should be good to go. Let me know if this helps.